Good day. Today we will be looking at November 2022, paper 2, question 4. Okay, the question says, in the diagram, M, which is 3 to negative 5, is the center of the circle having PN as its diameter. Okay, so that's going to tell us that PM and MN are equal. KL is the tangent to the circle, where N is 7 to negative 2. First question says find the coordinates of P, and I just said that M is the center of the circle, and if M is the center of the circle, that's going to mean PM and MN is equal. That makes M the midpoint. So let's write down our coordinates. We want P, X, and Y. N is 7 to negative 2, and M, which is the midpoint, is 3 to negative 5. So X of P plus 7 over 2 is equal to the midpoint, which is 3. Y of P minus 2 over 2 is equal to negative 5. Let's work with X first. We're going to cross multiply. Is equal to 6. So XP is equal to 6 minus 7. XP is equal to negative 1. I'm going to cross multiply here. So 5 times 2 is negative 10. YP is equal to negative 10 plus 2. YP is equal to negative 8. Therefore, my coordinates for P is negative 1 to negative 8. Okay. Going to our next question, 4.2.1, it says determine the equation of the circle in the form x minus a plus y minus b is equal to r squared. So we know that a and b is going to be substituted with our coordinates. We need to find the value for r. So r squared is equal to, and we can substitute n as the x and y. So nx is 7 minus 3, which is m squared, plus minus 2, n's y value, minus 5 squared. So 7 minus 3 is 4. We're going to square that. Be careful with your signs here. It's minus, and a minus gives me a plus. So that is going to be 4 squared plus 3 squared. So 4 squared is 16, 3 squared is 9. So r squared is 25. Now we can just give the answer in the form of what we need it to be. So x minus my m value is 3 squared plus y plus 5, because y is currently a negative, is equal to 25. Okay, the next question says determine the equation of KL in the form of y is equal to mx plus c. So in this question now, we need to consider how, always for when we want to find an equation, we need two things, gradient and c coordinates. So if I can get the gradient, I can easily find c by substituting n in. But how am I going to find the gradient? So what we know is that this is the center of the circle, and we know that it creates that the radius is perpendicular to a tangent. So that is 90 degrees. And we also know that gradients are related when they are perpendicular. So if we can find the gradient of mn, we can use this perpendicular, the theorem that it's perpendicular, to help us find the gradient of KL, because what is the rule is that gradients that are perpendicular, when they multiply each other, is equal to negative 1. So we can use that to find the gradient of KL, and thereafter it should be easy to substitute. So the first thing that we're doing is finding the gradient of mn. So y2 minus y1 over x2 minus x1. So n values, we've got minus 5 minus 2 over 3 minus 7. Minus 5 minus minus 2 is going to be minus 5 plus 2 over 3 minus 7. So I'm going to have 3 over 4. Okay, and what did I just say? When gradients are perpendicular, mn times the gradient of KL is equal to negative 1. So this is 3 over 4 times gradient of KL is equal to negative 1. Gradient of KL is therefore going to be negative 4 over 3. And we know that they are perpendicular because the radius is perpendicular to the tangent. Okay, now that we know that, we can now substitute and find our formula. So y is equal to negative 4 over 3x plus c. We're going to substitute n because n is sitting on KL. We're going to have negative 2 is equal to negative 4 over 3, 7 plus c. Let's multiply. 7 times minus 4 over 3. It's negative 28 over 3 plus c. So we're going to take this to the other side. And we're going to use our calculator to give us the answer for c. Minus 2 plus 28 over 3. It's 22 over 3. Make sure you write your final answer out. So y is going to be equal to negative 4 over 3x plus 22 over 3. Okay. Now, let's look at the next question. The next question says, for which value k will y is equal to negative 4 over 3x plus k be a secant to the circle? So it's important that you know what a secant is to a circle. And I'm going to draw it now so that you can see it and that you will be able to visualize the different parts of the circle, just so that we can revise this. Okay, so we have a circle. You've got a center. You know that the line from the center going to the edge is my radius. Then we also know that it going right across is my diameter. And we have already spoken about the tangents. So the line going across is a tangent, but it's not within the circle. A line that's not the diameter that's going across, that is what we call a secant. Okay, so it's in the circle, but it's not on the outside. And then the last part is from one point of the circle to another point of the circle. That is called a chord. So this is just terminology related to the circle. So here they are saying for which values of k will y, the equation that we just calculated, but which y values will be a secant to the circle. So looking here, it's most likely going to be values related to p. And we're going to have to find the c values that are related to if it were to be here. So basically along this line, y value here. So what is that y value there? So we're going to make my y value negative 8. We're going to substitute p basically into the equation. Okay, and we calculated p. So negative 8 is equal to negative 4 over 3, negative 1 plus c. So negative 8 is equal to 4 over 3 plus c. Negative 8 minus 4 over 3 is equal to c. So c is going to be equal to negative 8 minus 4 over 3, negative 28 over 3. But that is not the final answer. The final answer is going to be, this is basically the restriction point, and then the point of the y for KL. That is where secant can lie. So it's going to be negative 28 over 3 is less than k, which is greater than, k is greater than negative 28 over 3, but it's less than 22 over 3, which is the actual y value, y-intercept for KL. Okay. The last question is 4.4. 4.4 says points A, which has TT, and B are not shown in the diagram. From point A, another tangent is drawn to touch the circle with center M at B. Show that the length of tangent B is given by root of 2t squared plus 4t plus 9. Okay, so technically they're creating a Pythagoras triangle. So AB squared is equal to AM squared minus MB squared, because they're saying from point A, another tangent is drawn to touch the circle with center M. And we know that when a tangent is drawn to touch the circle, it gives me a 90-degree angle, okay? And then there's another point B somewhere. So that is creating a Pythagoras triangle. So that is why we are calculating now we want to calculate AB. We know that there's a 90-degree. So AB is what we're calculating. We know the coordinates for M. Our coordinates for M is 3 is to negative 5. And we know what A is. A is TT, so we're going to substitute TT. And we know that MB squared, which is my radius, so here's M, here's B, and let's put A there. We're calculating AB, and we know that MB is the radius, so that is 25. So let's start with AM. So it's going to be T minus 3, which is M squared, plus T plus 5, here's my 5, squared, close bracket, minus 5 squared, which is 25. Now we can simplify. We're going to expand, plus T plus 5, T plus 5 minus 25. So we're going to get T squared minus 6T plus 9 plus T squared plus 10T plus 25 minus 25. Now if we simplify, we're going to get 2T squared minus 6T plus 10T is plus 4T plus 9. Because it's AB squared, we just want AB, it's going to be the root of 2T squared plus 4T plus 9. Oh, I'm sorry, it got cut off there. So I'm going to re-explain what I did again. Okay, so we said AB squared is equal to AM squared minus MB squared, and we drew a small diagram to demonstrate. We have coordinates for A that we're going to substitute. We know that M is 3, negative 5, and we know that MB is the radius, which is 25. So with working with AM, we're going to say T minus 3 squared plus T plus 5 squared, and with MB squared, it's 5 squared, 25. I expanded T minus 3, T minus 3, T plus 5, T plus 5, and then we cross multiply. T squared minus 3T minus 3T gives me minus 6T, minus 3 times minus 3 gives me positive 9. T times T, T squared, 5T plus 5T is 10T, and 5 times 5 is 25, minus 25. So then we can get rid of that. 2T squared plus T squared is 2T, minus 6T plus 10T is positive 4T, and 9. And because this is AB squared, we want just AB, we square rooted it. And that corresponds to what they asked us in the question, and we have what they asked for. Okay. The next one which is 4.4.2, says determine the minimum length of AB. And to find minimum length, we can use the derivative of the previous question. So the derivative is 4t plus 4 is equal to 0. Therefore, 4t is equal to negative 4, t is equal to negative 1. And then we can substitute t into the previous question to find the length. So AB is equal to 2 negative 1 squared plus 4 negative 1 plus 9. And that, if you put into your calculator, is root 7. Okay, quickly taking a look at mark allocation. The first question, this last question was 4 marks. 1 for derivative, 1 for the negative 1, 1 for substitution, 1 for your answer. The previous question was 2 marks, even though it was quite a lot to do. We're substituting into Pythagoras and simplifying for 2 marks. The one where we had to find the secant was 4 marks. Substituting P, finding the value of C, and the answer was 2 marks for 4 marks. And then 4.2.2 was 5 marks. 1 for substitution, 1 for each of the gradients, another substitution, and 1 for finding the equation, 5 marks. Equation questions are generally a lot of marks and fairly easy to get done. 4.2.1, 3 marks, substituting into the formula, your values at the end, and 25. And the very first question was just 2 marks, 1 for your x value, 1 for your y value. And in total, this was a 20-mark question. Thank you.